It's yours.
Hey everybody, we're Group National, Phase 2 of the second semester. I'm Daniel, there's Billy, Wade, and Max, and our coaching and wonderful coaching and sponsors done by Bill Stumbo and Jack Becker. So for the app, to give you a brief overview on what we're doing. For the beginning, we'll be talking about the product, we'll be talking about why this product was made in the first place, what we inherited, and also what changes we made to it. And then we'll be showing the demo for the process. We'll be talking about what we had in the original base to help us guide us while we were working, and also what updates we made to help improve our process to better fit our sponsor. For the technology, we will be focusing on the development infrastructure and architecture. And for the takeaways, we'll be talking about what went well, what went wrong, and what improvements we can make in the future. So the original problem was that what the original thing this application was needed for was that Jack needed a way to send classes to SIS so that they could put that up and students could begin to enroll in the classes. The problem is, as you can see from the Excel sheet here, it's really clustered, hard to read, and can become disorienting when you're looking at all this information. And also it's really cluttered and only shows the rooms that are currently used, which can cause some conflicts whenever you're dealing with like multidimensional data, such as what time of day it is, the prerequisites, scheduling those apart, and also making sure you're not conflicting with the instructor's schedule. And also, you need to account for other layers of things such as room size, so you know you don't schedule too many students, and if you put that in there, it will just clutter it up more, and it also availability. So these are the feature lists, and as you can see, we have the original product, the end of the first semester, and the current product. So the original product is what we inherited, the end of the first semester is at the end of the first semester, and the current one is what's going to be shown during the demo. Some of the key features here is the display rooms, which, as you can see, they're static and dynamic. So originally it was built in code. So originally it was built directly in the code and not inherited through a model, so that you would have to rewrite it for each floor you have. But for the dynamic, it now is able to be reused for multiple floors and rooms in the future. Another key feature is the calendars. So as you can see, there's a block in the middle. That's because originally we were focusing on refactoring in the beginning, and we were focusing on that, and we were able to get that up for the first semester. But after we were able to get going, we were able to have it on a single flow view on the map. So that way you can still see the major map of the rooms without having to leave the screen to see the calendar. And then finally, one of the most important ones is the duplicate semester schedule. And the reason why this is important is because every semester there's a lot of similar rooms, similar courses and such that needs to be carried over. And to reduce the amount of busy work, it really helps whenever they are able to reduplicate that so that they only need to make some minor adjustments for the next semester. Now here's the original map UI. You can see that the color here doesn't match up with the RIT branding because we grouped for it, so we didn't have to consider that. And also this is the static page. You can see that there's no way to switch floors, and you can reserve a room by clicking on the room and then clicking the reserve button, which would take you to a different page where you could schedule the room that you wanted to that would cause these green colors to turn red. And this is a dynamic page, static page. And then here is what was done at the end of the first semester. As you can see, there's now a semester one, so it's done by semester, and then there's a day and a time, and you can see it flows out now, so that you can do it all on one screen without having to change, so you can see the updates while you make the changes. And also, another thing about this is you can see that there's now arrows here, so you can switch floors and rooms as that functionality. The problem with this one is that at the end of this, it focused purely on the scheduling aspect, so stuff like scheduling courses and the calendar aren't in the flow. So it focuses purely on the functionality, but the UI wasn't, the usability isn't perfect for Jack. And now as it loads, I'll hand it off to Bill.
We'd like to proudly present our demo. Just kidding. So the story for this demo is something we've gone over with Jack in the past. Like Dan mentioned, we want to be able to duplicate semesters. So when Jack makes a new semester worth of schedules, he really wants to reuse a lot of the data from the last semester. So we're going to showcase how he might go about scheduling a class in that way. So we're going to start out the second floor of Gannett in the map here. You see that all of the rooms are free. This is a semester with no data in it right now, but we're going to go and add a semester that will have data. So we're going to go to create a new semester, and we're going to say fall of 2021. So when you usually create a new semester in the system, it won't have any data in it. It's sort of a blank slate. We realized a couple months ago with Jack that he wants to be able to reuse data from old semesters, like I said, because there's a lot of overlap there. So we're just going to create this new semester like you would normally, but we have a copy schedule from template semester here. So what's going to happen is I'm going to click into that and select fall of 2019, which already has scheduling data, and we're going to create it. And you'll see, as you expect, the new semester will show up, fall of 2021. And we're going to go pick it in the top right. The semester is a context that follows you around the app, so when you're scheduling for a semester, it's just going to stick around with you the whole time, and it'll always know your semester. So if you check Frankenet Hall, floor 2, you'll see there's a red room. That means it's busy right now. So you see the scheduling data copied over from the last semester. And what we want to do now is create a new course to accommodate for more students, or a new section for a course. So we're going to check with Jack's schedule first to see when he's free, because he'll be teaching it. It looks like he's free from about Tuesday, 8 to 10 a.m. So we're going to aim for that. When we create our new section, we'll do production 1. So we're going to go up to manage, courses, and then in production 1, manage sections, and we can add a new section. Section 2, it'll have a capacity of like 30 students, and as mentioned before, this will be Jack's class. So we'll register it under him. Unlike the other one, you'll see that has no scheduling data so far, so it's a blank slate for us to schedule. So we'll go back to the map. Jack's really excited for the new building Magic Spell Studio, so why don't we go schedule there? We'll go to the lower floor, and we'll see that there's a lot of availability here. We'll go to Tuesday when he's free. The default time is 8 to around 10, so that works for him. And we'll check what the theater is like. Well, it looks like the theater is free all day, so that's all Jack's if he wants it. So we're going to go SOFA 101 in the search box, and you can see both sections pop up, but we'll pick section 2. We can go into the theater and click schedule this room, and just like that, now it's taken. Click into it, you can see the schedule. 8 to around 10 is when production 1 is. So now we want to schedule again, since we already have the course selected and stuff. So let's say we want to try for a Wednesday class, get this out of the way early in the week, and free up the end of Jack's week. So the schedule's free, everything is still selected from last time. It's pretty convenient, you can just go and try and schedule again. So we're going to do that. But there's a conflict. If you remember, Jack's busy Wednesdays in the mornings. So we could override it and schedule anyways, but we're not going to in this case. So when is Jack free? Well, if you remember, there was a bit of a block on Thursday afternoon, so unfortunately for Jack, we're going to be giving him a night class. We're going to go to 4 p.m. here. And then we're going to end around 6:50. Either way, it doesn't matter, just needed a time where he was free. And go in, and we'll schedule it. No conflict anymore, pops up in the schedule. That's how it is right now. So we can go back to the manage courses, go into the sections, and you see the scheduling data is right there, as you'd expect. Jack's teaching it, just like we said. And then we'll go up to confirm Jack's calendar. And you can see it's a lot more filled out, unfortunately, with an 8 a.m. and a night class, but that's just the way it goes. But now that we have this new scheduling data for the semester, Jack needs an artifact to give to the registrar. So you just click the download button, and you get a CSV. That's the end of the recorded demo. Let's get this back into full screen. But here's the output for our CSV. So this is basically what Jack would hand to the registrar. You have all the different sections, what course they belong to, the instructor, the day and times, the rooms, and the number of students, all handled for Jack. He doesn't have to touch a spreadsheet at all. He just uses the system and hands this output right to the registrar. Now that I've showed you what we have built, I'd like to hand this over to Wade so that he can talk about the process with which we used to build it.
Thanks, Bill. So last semester in the fall, we had a pretty well-defined product that we were going to try to re-implement. We had decided that the technology wasn't exactly where we wanted it to be on the client, and we were going to reuse the API and build up from there. So that meant that we had a pretty clear path, because we were rebuilding the UI, that we could just break that down into little tiny tasks to build out and go from there. We did this with a pretty simple iterative Kanban process. So we have tasks on GitHub issues that are organized into a Kanban board. Each of those issues have an assignee, a status either to do, doing, testing, or done. Priority high, medium, or low, depending on how critical that task is to the success of the project. and a t-shirt size to size up relative to other tasks, how much work about do we think it might be. Now, that was pretty simple in the fall. Moving into the spring, we were going to be defining new user experiences and experimenting with new ways of interacting with, the system and the user. So we had to split off into sort of two parallel paths. Sometimes you would be defining new work, experimenting with wireframes and asking questions, how should a person, think about this scheduling business? Well, the other times you were actually taking those tasks that we've decided, yes, this should go into the product, building it, and pushing code. We shifted our process a little bit in order to reflect that split.
So last semester, since we didn't really have much to show Jack until the end, we started with just doing 4-ups and questions every day. And this was a very one-way street sort of interaction. We talk to Jack, we tell him what we're doing, and we ask him questions, and that's really his only chance for feedback. We want to involve him more, since he's going to actually be using the system, so that we make the system not only functional, but usable for him. So we broke down our meeting structure so that we would now start with wireframes. If we had any wireframes for a future feature, we would show them to Jack, we would take notes on them, and he could give feedback, and it would help us implement. He would get hands-on with the product. Usually it's something that he got a chance to look at the wireframes for a couple weeks prior, and then we would move up onto the 4-up and questions. Since our meetings were capped at about 50 minutes, if we didn't get to the 4-up, that's fine, because that's all documented in emails, and we can ask Jack questions over email. But this gave Jack 2 new chances within the process to give his feedback. And this also created an asynchronous pipeline. We were big on developing independently and asynchronously of each other. So I might be working on a feature that's currently in wireframe, I hand Jack the wireframes. Wade might be showing him something that has a hands-on, and would be taking that feedback, and we'd work on these features together so that we could build the product the way that Jack would want it. And if Jack ended up not liking anything from the hands-on, we could always restart the process from square one, ask him what he wants, and go back to the design stage. So a good example of how we did this, I think the first feature we did this for was calendars. Jack didn't have any huge feedback for the layout of this. Obviously, it's a calendar. It's not hugely complicated. But what's important is this also sparks discussions about our requirements and underlying system. You might not be able to see it, but at the bottom, we found out at this point that Jack wanted to allow for conflicts in the schedule. Like you saw when we had the pop-up, you could choose to override that. We previously thought that you didn't want to have that at all, but this sort of sparked a change in architecture mid-semester where we did allow for that. So even if there wasn't much feedback on the wireframes that changed how it looked, there was feedback on the prototype. So this is what I ended up showing Jack a week or 2 later. And one big thing he noticed, one of his biggest things about the system is he wants it to be easy to use, and he wants it to be everything. You just view it and get an idea for what it is at a quick glance. This does not solve that problem because you have to scroll to the side and everything's way too big and spread out. And he also wanted to add Sunday as a day as well to the calendar, and he wanted it to go down to 11 p.m. So now that we got Jack's feedback on this, we have this, which we finally implemented and showed off in the demo, where we have everything on one page. It's compressed. You can get it in a quick glance. You do have to scroll down a bit for the times, but no side scrolling for the days, which is great. And we don't have to redo this after implementing it because we knew what Jack wanted through the process, which I think was better overall for our usability. So now we talked about the process, I want to hand off to Wade again to talk about our architecture and infrastructure.
Cool. Thanks, Bill. So Bill just walked us through this whole process of defining requirements into designing some sort of implementation and implementing that. I want to talk a little bit about how we take that implementation and put it somewhere that Jack can actually use it. So we pretty early on started talking to College of Art and Design, really cool guy named Brad there. He told us about their Kubernetes cluster, that if we wrapped up our project with Docker, it would be pretty easy for him to put it into production, and that contract held up true. So in order to do that, I wrapped up our React application in a Docker image that in CI, every time we push, triggers a CI process that builds out static assets, wraps it up in an Nginx Docker container, and then just passes that along to production, so we don't have any node running in production. And then on the API side of things, we do have an instance of Python running so that we have a Django server that is actually there. There's no way to compress that down to static assets. So that actually runs in a Docker image, and all of this gets wrapped up into a third image that gives it a single point of entry that goes to production in one bundle. So this is what that stack looks like in production. We do have a Postgres server sitting underneath Django, not that that particularly matters. We could swap it out for pretty much anything we want. It's also really nice that CAD provides this for us, so we didn't really need to stand it up on our own. The sequence diagram on the right describes a really simple use case that Billy went through in the demo. This is when you create a reservation, when you actually click on an available room and click the button to reserve it. The user, that is the action of creating a reservation that I just described. The UI reaches out to the API reaches out to the database, and everything comes back. And if all of that works, it should display to the user successful. That should be familiar to anybody who's used REST or CRUD applications before. Pretty standard technologies. The point of this is that we should be able to hand this off to another team next year, and hopefully they shouldn't have to start from scratch like we kind of did.
All right, so you've heard a lot about the front end so far. I'll talk about the back end a little bit. So our focus this semester, some of the key features and refactorings was the reservation conflicts, whether when you're making a reservation, if the room conflicts with another reservation or the teacher schedule conflicts, adding that in, also adding the force in case, for whatever reason, Jack needed that. Also helpful error responses so that if you had some sort of conflict or some other error, you'd be able to know this is a room conflict and be able to alert the front end of that and the user. So again, copy semester. Duplicate semester was a huge feature that Jack wanted that we figured out midway through this semester. So we were able to implement that. Just several endpoints for all the various needs and all the data that they need on the front end, and several refactorings based on the changed requirements. So some mentioned before, but also teacher optional was one. So when he was creating a class, he realized that he didn't necessarily know the professor that was going to be teaching it. And then room unreservable. Not all the rooms that were on the map were reservable, so we learned that and updated that, so you can't reserve an unreserved room. Testing. So we had unit tests. We had strong unit tests first semester. It slowed off a little bit second semester. I'll discuss that later on. But then Postman as well was great for testing various network calls and to help document the endpoints so the front end could easily implement them. So kind of the takeaways, what went well. The first thing that came in mind, team chemistry between the different developers and also the coach and sponsor. We always would have a good time and Jack would crack jokes all meeting. Also, we had weekly meetings with wireframes and hands-on. This really added a lot of transparency to our work and gathered a lot of useful feedback, whether it be UI-based or requirement-based. And again, the requirement elicitation was a continuous process, so we did change it throughout, but our architecture that we designed in the beginning allowed for that change. So also another great thing we did was focusing on key features. We always had MVP in mind and kind of what Jack really wanted to, what features would be best suited for him. So we kept that through the fluid scope, and yeah, the back end, we actually got to complete all the features that were needed for the MVP, which was great. We also had a feature freeze, which was really helpful. So a few weeks ago, we stopped our development. So the last couple weeks, we've been focusing strictly on bug fixes and time for documentation, etc. And the prioritization of the CAD communication with Brad. We started talking to him early because we figured we'd run into issues, and we did run into issues, but we had enough time. We got to figure out most of those. So what didn't go well? Testing, unit testing. After kind of the crunch at the end of the first semester, we struggled a little bit with time for adding unit tests, and this kind of continued. We focused on features more so. Time management, right after spring break, there was a little bit of lull in productivity, and part of that was a process issue. We had a crunch time at the end of the second semester, which I'm sure many other teams faced, and it kind of rubber stamped the code reviews, didn't take a good enough look at the PRs and authentication with CAD. We had a lot of difficulties with that. And the last one is not moving a project to GitHub. We had our process. We had the project on GitHub and process on, or project on GitLab, process on GitHub. So kind of improvements. Basically, stay on top of the testing and tech debt. Make sure we reserve time for that. and then more structured process. So weekly itineraries, more formal code reviews, paired programming, all process and code in the same place, testing manually more, and then more bite-sized work. So our t-shirt estimations could have done some reworking, but overall I think it worked well. Questions?
I noticed during your demo, it looked like some of your views at the end, you showed examples of the calendar, but they were lacking the actual room assignment in both the calendar view and also the class view. Was that an oversight, or was that reflected by the?
It's an oversight. During our wireframes and demos, the customer never asked if he could see that information. I think I even offered at one point, like, hey, we have this, but it just wasn't deemed useful.
Okay, because it was in your output, your Excel file.
Mm-hmm. Yeah, that's required for the scheduling marshal. They need to know what room it's in, but if you're looking at it just to see when an instructor is available, you don't necessarily need to know what room they're in. You just need to know that they're not free then.
I noticed in your demo that when you were creating the new semester, you had an option to sort of choose an older semester, that it was just a drop down. Do you think that might become problematic, if this continues for longer and longer periods of time, you get more and more semesters, or is that something that you kind of just think your drop down is going forward?
I think that's definitely a possibility. Obviously, I think a search function might be better in that place. But for the scope of this, and within the next 8-10 semesters, it should still stay on the page. If there is a next team that takes over this, that would definitely be a great usability improvement to include.
With regards to your design issues, what are you most proud of? Because you made reference to, and hopefully the next team, right, won't have to throw you under the bus. And, so, what do you think might be the most, salient aspect of your architectural choice?
I really liked the way we allowed for custom room shapes. As Dan mentioned, the last team sort of put all the rooms in manually in code. But with this, we didn't mention this semester, but in last semester's presentation we mentioned it. Jack was thinking of expanding this maybe to more departments or to even outside of academia. This way we don't limit the system to having only, first of all the buildings would be in source control. We feel like it might be better to have it maybe as seed data if it is in source control, but it also gives you the freeformness that this doesn't have to be limited to the buildings that we currently have. So we make it open-ended so that future teams can add whatever buildings they want. A big difference between our team and last team is that the last team only had to worry about Cadet, but we had Magic Spell Studios. If there is a next team and Jack's department gets a new building, we wanted to make it as easy as possible for them to add that in as well. So I feel that that was something that I'm proud of, but also something that was very ambitious, and having to go in and add the specific room coordinates was kind of a lot, and it'll be hard to make a UI flow for it, but I think it was probably the most forward thinking of our architecture about where this could go in the future if Jack does want to take it outside of academia or to different departments.
So along those lines.
Hi everyone, we are the Multimate team, or the team behind Multimate, and so I'm George Hurdy.
I'm Shannon.
I'm Josh. And I'm Steve Teflica.
And we have 3 members of our team that we wanted to highlight before we got any further. We have our pair of sponsors, Paul Craig and Herbert Bernstein, who have both been fantastic sources of enthusiasm and excellent at answering questions as we learned the field of structural homology and got all of the domain knowledge that we needed to be able to do this project. And our faculty coach, Professor Kaiser, provided insight and autonomy to our team that allowed us to succeed and make the project that we're presenting now.
So for a little bit of background on our project, our domain was very specific, and this was actually a big challenge both last semester and into this one, was our team being able to understand this field of study. So it can only really be described with very specific terms. So we're actually going to start with some definitions. That way you guys have the context required to understand the product we've built. So the first thing here is protein function analysis. This is essentially the purpose of the software that we've created. This is when you have a lot of proteins that have very defined, well-known functions, something that they can do. And you can compare it with a protein that you don't really know what it does. And that will be able to let you figure out and provide insight as to what that unknown protein might be able to do. So you do this through something called an alignment. Here we have a visualization of what an alignment will look like. This is essentially when two proteins overlap in a specific area. So that area that we know to line them up in is known as an active site. For the purpose of this presentation, it's essentially where stuff happens. It's the part in the protein that has the ability to have some sort of reaction. And lastly, we have motif. We'll use this multiple times in the presentation. This is the template and the format that we use in order to define a protein structure. So, last semester, we were presented to take and modernize a desktop application known as Promol. This project is pretty old, and it was very slow and had some usability and performance concerns. So before we wanted to show you guys what we had recreated, we want to run through first, give you a little more context as to how this product is meant to work. So here we have the original view of Promol, and this is for the ability to search and do one of those alignments. If you see in the medium-sized white rectangle, we have a protein ID. What you can do there is insert one or many proteins to be able to run a search on. Next, if you press search, this pop-up will show up. It has a bunch of filters in it that you can apply to part of the search. So then, once you press select, you have to wait several minutes. Promol is incredibly slow, and so if the program doesn't crash in the process of trying to get results, we'll have them displayed on the far side. Once you decide which result you want to click, you click on it, wait about 4 seconds on average, and you'll get a protein visualization. Here you're able to interact, click on specific atoms, as well as run calculations, and those will print out in that top terminal style box at the corner. It can be kind of hard if you're doing a lot, as you'll have to scroll up and look through for all of that information. The second core function that Promol offers that we replicated is Motif Maker. This is what it looks like in the original Promol software. This allows you to make a custom motif. This is useful if you're researching or maybe a company and your protein isn't publicly known. The one specific call out for Motif Maker is the ability to turn off backbone up at that top side. Essentially, the backbone helps make results more accurate. And it takes a lot of time to run results if you do enable backbone in Promol. So they've created the ability to turn it off. That way you could speed up the results, but your results are going to be less accurate. So this is a workaround in order to prevent the program from crashing and to try to get results quickly.
So now that we've covered the old software, we're going to be talking about our project and how we've implemented it, some of our design decisions that were involved. The first thing that we're going to talk about are the features that the sponsors wanted us to implement in the new version of the software, Multimate. The first major feature that we wanted was motif search. Motif search allows you to search among a set of motifs using a certain protein or set of proteins, and you can see which motifs it aligns with. For the search, you can filter based on EC class or precision. The precision factor allows you to adjust how strict the alignment is. And then, the next major feature we have is Motif Maker. Like Shannon said, this allows you to create a motif. When we have these motifs that we make in Motif Maker, we also allow you to test and download these motifs. In order to test a motif, there are several types of tests that you might want to run. The first type is a self-test. This is essentially a sanity check. We want to make sure that when a when we make a motif, that it aligns with itself. If it doesn't align perfectly with itself, there must be some problem with your motif, and you don't want that. The next kind of test is a homolog test. What this does is we take similar proteins that we find on the protein data bank, and we take your motif and align it with all of those. And we show which ones it does successfully align with and which ones it doesn't. What you'd expect for your motif to do is align with other proteins that are of a similar enzyme class. Next, you can test along your own set of proteins. And lastly, you can choose a number of random proteins that you can test your motif against, and it'll run against those. This is great for checking for false positives. If you test against a set of random proteins and you find you're aligning with all of them, it might mean that your motif is a little bit too lenient. So the next thing we're going to talk about is our architecture. One thing that we found was that our tech stack is fairly standard, so for this we're going to focus on our cloud deployment architecture. The first thing that we did was we actually had it originally implemented as two separate services for the front end and the back end. This seemed like a good idea at the time, but we found when we were deploying that this made things a little bit difficult, and we could improve this by compiling down the front end to a static asset and keeping that packaged in with the back end. And then what we do is we deploy this server on Google App Engine. This allows us to have just one service running, and it saves costs in the cloud. As you can see, we have our server running in the App Engine service. We have our motifs stored in a Cloud SQL database, and we have other static assets stored in a bucket. This also allowed us to stop using Docker, which was a part of our original deployment plan. Lastly, we did cover a use case with our sponsors where there was a possibility of maybe they want to run this server on their own, not on the cloud, but on their own machines. In order to facilitate this, we also compiled a jar file that's executable and easy to port and send to any machine. So the next thing that we want to talk about are some design decisions that we made and some kind of trade-offs that we had. One of the big trade-offs that we kind of did a lot and is sort of a recurring theme is we traded memory for other things. One of the big things that we did was we chose Java and Spring Boot as our backend. What this ended up kind of having us do is it forced us to use a lot of memory. This is a relatively memory-heavy server, but the reason we did that is it allowed us to be more productive. It was kind of an environment that we were all a bit more confident using. It also made us a bit more flexible in terms of like database choices or the actual type of server that we're running, whether we want to do Jetty or Tomcat, which saved us for Google Cloud because the Spring Boot default is different than what Google Cloud wants. The next thing that we did, which was a huge performance boost for us, was implementing a two-layer cache. And this basically has an in-memory cache that empties into a database when it overflows. This alignment cache is really great because it helps us speed up the alignments, because although we were able to get them faster than how Promol ran, they still take a while. The trade-off for this is, of course, memory for the in-memory cache and disk space. But we traded this memory for a 100 times increase in speed for these alignments if we get a redundant response. So the next thing that we want to show is some performance improvements and have some nice numbers here. As you can see, the time for a standard search alignment was 675 seconds on Promol. After we re-implemented the alignment algorithm in our system, which we did last semester, we got that down to 90 seconds. And that just happened to be actually mostly just because of the technology that we used versus how Promol was built. After we have the cache, when we run, so for some context, that first alignment speed for 90 seconds, the first time a server gets an alignment request and it has never computed this before, it'll take 90 seconds. But afterwards, we don't want to have to recompute that again because we already know the answer and the answer never changes. So after it's cached, it actually takes less than 1 second to run the alignment again. And that's really great. Another thing that we improved upon was the display speed. It does take a while for Promul to actually bring that window back and show the visualization. For us, our visualization takes, once again, less than a second.
So now we understand the project origins and how we got to where we currently are with our project. And so the next thing is to talk about the debut, the first time we actually showed this project. So about 2 weeks ago, our sponsor, Paul, went to a conference in South Carolina at this university, Fayetteville University, and he actually held a workshop there where 15 students who had never used this tool before or had even heard of it used it for the first time. And it was a success. They were able to use our tool, and it didn't have any crashes. They were using our cloud host version of it. I think a very important thing to bring up as a part of this whole conference and anecdote is that Multimate and the session that was held around it was just about 1 hour out of a very long day for the conference. Other workshops held there dealt with different tools that are used for bioinformatics and all sorts of things like that. And what that means is Multimate is not meant to be a one-stop shop to handle everything that is bioinformatics and biochemistry, protein analysis, and all this. It's meant to be one working part that does its job very well. People come into here, they do a little bit of research in it, and then they export results to other tools that are better at different things. So we're going to get into a demo in a second, but before we do, I just wanted to show you what a good and a bad alignment might look like. So this is a picture of a good alignment. You can tell because there's two, it might be hard to see at first, there's two overlapping active sites here. You can see two different colors, there's kind of a bluish and a greenish color here. They look like they're just kind of interleaving because they are almost perfectly aligned. These are two separate proteins whose active sites align very well. Another metric we can use to determine that this is a good alignment is looking at the bottom left. It says RMSD. That's just a distance metric. It's root mean squared deviation, and all it means is how close are all the atoms on average. So this is 0.14. That doesn't mean anything yet. We'll go to the next one. This is a bad alignment. You can see the blue and the green residues, which is just the collection of atoms. They're very far apart. They might look the same, but spatially they're very displaced. And just to verify that this is a bad alignment, we again look at the RMSD value at the bottom left. It's 7.1. So 70 times bigger than the previous one. With that, we're going to pass this off to Josh and George to talk about the demo.
So we're going to take a look at our video, and we wanted to contextualize this demo in a way that the students at the workshop or how Multimate might be used in general. So we start off on the protein databank, which is a public repository of proteins. And so 4EZI is the protein that we're going to be looking at, and right now it has an unknown function. This is publicly available. There's research going on at RIT and other places to try to figure out these different functions. So we can put 4EZI into Multimate and go ahead and hit search. In reality, when I was doing this video, this search took 96 seconds, but I sped it up for convenience. So if we go ahead and scroll down, we can see quickly, these are our list of results with the EC class. Shared EC class means that the structure is going to be very similar, it has a similar function. In our first alignment, we can see quickly that our RMSD is pretty low. And the alignment is really great, actually. All of the residues are on top of each other, and we're able to pan and rotate the visualization. As you can see in the top right, where our details is, our EC class for 4EZI is unknown, but we have the EC class of, I believe, 3113. We added quick links back to the PDB so that students who found a motif from our database could get back to the overarching information pretty easily. What we have listed below each of our identifying names is the residue name. And so, for example, the motif has 3 residues, a serine, an aspartate, and a histidine. And so when we're doing the alignment, we're looking for those residues in our query structure. And then we are confirming that the distance of each atom in those residues is appropriate to the relative distance in the motif. And then finally, we added, so while we do truncate the RMSD, we are calculating it all the way out in the back end, and we included the nifty feature that if you click on it right there, it'll add to your clipboard. And you can hover in the visualization over the different atoms or the different bonds. So it's going to take a second. So we're going to go and we're going to look at a bad alignment, or one with a higher RMSD. These results are yes, they fit the query structure of, this atom needs to be within this range of, this other particular atom. However, as you can see, the structures are actually, or the residues themselves when visualized, they don't look to be matching the right way. And actually, in my hover order, I was trying to match up correctly. And so what we did on the right, and I figured out that I was wrong when I was doing this hover order, is we said, for example, histidine A327 matches with histidine A162. And since there's two glucose in this active site, it's kind of confusing so that the structures appear similar. And so you can confirm, oh, this residue over here, even though it's closer to this one, actually matches to this part of the motif. And again, you can click to copy the RMSD. I just also wanted to demo, if we do a repeated search or a cast search, it does come back almost immediately, and you can do all the same functionality, panning and zooming in. The other major function that we had, or feature that we had, was Motif Maker. And so we're going to start on the Catalytic Site Atlas, which is, again, a public repository of information which is highly documented and confirmed active sites. So a student or a researcher would scroll down to where the mechanism is listed, and we would obtain the information about each residue in the active site. So I quickly put in 1YPH, which is the structure that I'm looking at in the Catalytic Site Atlas, and its EC class. Then I put in each of the active site residues, and I'll jump forward a little bit while I'm typing on the screen. Going back to the 4 different types of testing, the first test I'm going to run is against self, and we'll see that the RMSD that is received is next to 0. It comes out to be like 4 times 10 to the negative 15. And then the second one, the homolog search that I run, we go to the protein data bank and we obtain all of the structures that share the EC class that the user inputted, so that we don't have to do any sort of hard coding or comparing of information. We just get it from the source of truth, the protein data bank. So we can see as we zoom in, now that we're testing against self, you might notice the flickers between green and blue. These, this visualization are literally directly on top of each other. Because you're trying to find the residues on itself. And these search times are actually live search times. I didn't speed any of these up. The first one was almost instant. We're only doing 1 alignment, 1 comparison. This second one, we do 70 comparisons, and it takes about 15 seconds. So we'll wait for this to run through. Out of the 70 comparisons from our list of homologs that we've obtained automatically from the PDB, we can see that this first one is a good alignment. It has a below 1 RMSD. You can see that some of the residues are shifted vertically off of their compared residue, but also because there's so many structures and they have slightly variations or otherwise, you might have residues that don't align or structures that don't align with your motif. So we wanted to make sure that we included those for the case of testing. And again, Josh mentioned being able to test against random, kind of confirm that you're getting true negatives. So we run these 10 structures, and they all return a failure. Thank you so much for your time. Is there any questions? Yeah, Justin.
If you're doing those random residues, you can randomly pick one that aligns with, and that's correct.
Yes, and so that's why we want it. So the question was, when you randomly select residues, because we get all 150,000 names, and we just shuffle and then pick the first 10 or the first 50, you might get a true positive from that selection. And so what that process comes down to is, since we're including the EC class, we can say, oh, well, for EZI, we don't know the EC number of, but it matches with a bunch of 3 EC class structures already. And so since this randomly selected a 3 EC class, that must be why it's a true positive. But it could also be a false positive, which is one of the reasons why the visualization is so important.
In your ideal future, do you see the product being stamped down a little further? I know you mentioned it's a very sort of cohesive and focused project. Would you want it to be extended any further though?
So we worked with our sponsor already to resubmit for senior project next year. And we talked to them about and kind of helped them evaluate the options. The functionality that exists right now ideally wouldn't be changed. And the goal of this new proposal that was submitted was to add new functionality. Ligand docking is a term that probably doesn't mean anything to anyone except for Paul, our wonderful sponsor. But that is the next kind of target set of functionality that would be added to the project.
What determined this order of the search results? Like it wasn't sorted by the accuracy. Like what was the order in that?
So search results are returned, currently they're sorted alphabetically. Our sponsor has requested to be able to sort them by RMSD, which is something that we're working on, and then also sort them by their EC class, so that 3.1 and 3.2 appear in order that way.
How early did you get that deployment strategy, and did you think it helped you developing productivity?
So for the deployment strategy, last semester we started working on deployment near the end of the semester. We actually started development pretty late last semester just because of learning the domain. So we kind of had an idea of a strategy and it involved a lot of Docker stuff. We got to where we are with the Google Cloud deployment stuff probably around the middle of this semester. So it did help getting there. We had to do a lot of fighting with Google Cloud, I'll tell you that.
Let's thank the team.
Cool. Hello, everyone. We are Team Core Sigma. We've been working with 2 Sigma this past year to deliver integration from one technology to another within 2 Sigma's own Beaker X. I'm John. Next to me are Ben, Daniil, and Brett. This past year, we've been working with Tizeng Li and Stephen Shi of 2 Sigma, and our project coach has been Professor Mohammed Makawar. So this is just a quick outline of what we'll be going over today. So we'll start with introducing Jupyter, BeakerX, and the concepts behind it. We'll then introduce the problem, the solution we were tasked with researching, our prototype, integration, and methodology, and finally we'll conclude with a reflection of our progress and performance during this project and what lies ahead in the future of this project. So, big data is a very popular concept nowadays. I'm sure many people in this room have heard of the concept. Generally speaking, it deals with a large and diverse amount of data that's constantly changing. Big data has grown in popularity as a concept because now more than ever before, companies depend on strategies to deal with constant flows of dynamic information as efficiently as possible. This requires developers to take a much more specialized approach to the process, solving the performance issues that come with handling such massive quantities of data. And the field of data science has grown immensely because of this growing need. But dealing with big data, data conversion itself also has its own fair share of problems. Data serialization and deserialization is very expensive, and languages have their own memory formats that all of them must adhere to. Similar functionality is then implemented in multiple projects over and over again, which can take time and effort away from development. Which brings us to Jupyter Notebook. Jupyter Notebook was originally the IPython notebook, if any of you are familiar with interactive notebooks in data science, and it's become very popular. It's become a very popular choice for data scientists around the world. Jupyter Notebook enables users to provide visualizations and analysis of data, and these notebooks can be used to share data with other users. However, one of the biggest problems that Jupyter Notebook has is the fact that notebooks can only be programmed in a single language, which is Python. So this not only limits a notebook's ability to use certain objects, types, and formats, but also prevents projects not written in Python from directly interacting with said notebook. And this is where this is where 2 Sigma's BeakerX comes in. BeakerX is an extension to the Jupyter Notebook, expanding on functionality that Jupyter lacks, most notably being unable to program in those multiple languages. And BeakerX enables polyglot programming, allowing multiple languages to be written to capture additional functionality and libraries not available in a single language. So this means that the data objects can automatically be translated from one language to another. And this auto-translation uses JSON to serialize the data. And this is because JSON is a very common data format. Its variety of libraries allows for implementations of data objects transformations. So we'll be going into a quick sort of demonstration to further contextualize BeakerX and Jupyter. And I'll hand it off to Ben.
So to give you a quick idea of what we're actually working on, I'm going to give a quick demo of BeakerX, how it works, and what it's all about while looking over my shoulder. So here we have a simple example of a notebook which has a block of code for Groovy and a block of code for Scala. Now this already is something new that BeakerX introduces, because normally only Python is able to be used. So if we process this block here, and wait for it, you can see that we get a simple output of the map that we just put in. And down here, from Scala, we can use the data that we found, that we shared up there. We could also go, you can set values that go any which way. If I process that, that'll be there. And then from here, we could read it back out. Now, okay. So, one common BeakerX use case that we have is to be able to process large amounts of data. In the example that you just saw, it was quick and simple, just like a 5-entry map that was being transferred between languages. But we want to be able to support use cases up to like millions of entries of data. Currently, JSON is used to share data. It's convenient because it's widely supported by multiple platforms and languages, but it's very verbose and it's not well suited for massive amounts of data. We were tasked with researching alternatives to this, finding one that's a good fit for the project, testing it to see what performance benefits we get, and that there actually are benefits to be had, and finally actually implementing the alternative. So this is what the This is an overview of what we were given, the existing project. It outlines auto-translation, showing the processes behind the sharing of values between variables and languages. On the right, you can see the actual process of serializing and sharing the data. This takes up a big chunk of processing time and would be great to be optimized. There's a lot going on with serialization, and performance, especially with lots of data, is a must. We want to improve this as much as possible.
So our solution for this bottleneck is to implement support for Apache Arrow. It's a relatively new development platform that provides a single common data layer, significantly reducing the need for cross-system communication. So instead of constantly transferring data between different system components, some of which that may be written in different languages, Arrow provides a language-independent in-memory columnar data format that serves as a bridge between both languages and components, eliminating the need for costly and possibly complicated data conversion operations. Arrow supports both flat and hierarchical data and takes advantage of new developments in modern hardware to increase its efficiency and reliability.
So last semester when we really started focusing in on Apache Arrow as the choice to improve our project, we quickly realized we needed some definable metrics to bring to the sponsor as proof of the improvement we would see. So we decided to come up with a prototype that would serialize large CSV files into the required Apache Arrow format as well as into JSON, and then we can compare the time it takes. The CSV files were actually suggested by the sponsor because of how often they use those, as well as how easy it is to generate large amounts of data. Looking at this sequence diagram, we sort of see an overview of what our proof of concept is. On the right side, it's pretty straightforward. You're serializing the data, you're writing it to a file, reading it back, and deserializing it. That's for JSON. One thing to note for our Apache Arrow on the left, you see the Plasma store. That is another tool from Apache called Apache Plasma. We're not going to go too deep into that, but basically it's an in-memory object store. So opposed to using the file like we do with JSON, we're using that with Apache Arrow. Ideally, both Apache Arrow and Apache Plasma would end up in BeakerX, but right now we're focusing mainly on Apache Arrow, as you'll see from the results in this slide. So as expected, Arrow outperforms JSON, and as we scale the data sets, the benefits we see scale as well. Reading and writing do see benefits. That's where the Apache Plasma comes in. But compared to the serializing and deserializing, you can see why we want to focus on Apache Arrow more than Apache Plasma.
So BeakerX is a large code base, and integrating right away isn't immediately obvious, the approach that we take. So before jumping into it, we took time to learn the code base and figured out what code actually needed to be changed. Before we started going into an implementation, we combed through the code base, kept track of findings in a spreadsheet, and recorded things like important places in code, what the code's doing, and how it needs to be changed. So we found that the main place that we need to change is an interface called the BeakerX client. This interface defines how shared variables are read and written. It has get and set methods that are called every time that variables are written or read from the notebook. Existing code is implemented by serializing values with JSON, and after they were serialized with JSON, they'll be transferred and shared between languages over HTTP. To change this, when we integrate, we'll be using a decorator, which will let us use the existing code that's there. We're going to wrap it around, wrap the existing implementation, and every time set or get is called, we'll intercept it, store the data with arrow, and then send a smaller piece of JSON that references the object in arrow. So on the left, we have a simple example of common task, storing data in a map and reading it back from somewhere else. The existing implementation, which you can see in the middle, when it's set from Groovy, the map will be serialized into JSON and then deserialized right away from Scala. This works well for small data, but it can be become a bottleneck quickly. With large amounts of data, serialization will be slow, and then deserialization as well. So on the right, we have our approach as an alternative. On the top, you can see our decorator class. Whenever a value will be set in the notebook, it'll call our own set method, and then we will serialize that to arrow and store data in JSON. We pass the arrow object we made with info about where it is in arrow to the original implementation. That does all the same transferring it did. And then when we read it back out, we deserialize from arrow. Yeah.
All right, so shifting gears a bit. So this past year, we've been using the Agile methodology. Several tools were used to keep track of everything over the course of the semester. Trello was used as a Kanban board to groom user stories and keep track of progress, and Slack enabled team communication. Weekly meetings with the sponsor enabled us to discuss progress and blockers, and our sprints were bi-weekly, which can be generalized across 4 different phases. A requirements and story elicitation phase, where discussion with our sponsor and each other helped to figure out what requirements need to be fulfilled during the sprint, and story grooming, where once eliciting enough details from our sponsor would lead to creating and grooming stories. The stories were rated using Planning Poker in terms of difficulty and time estimation, and the majority of the time after that would be dedicated to research and development. Some sprints would be research heavy, while others would be development heavy. And finally, within the last 2 hours of the sprint, and meeting with our sponsor once again, we can look back on what was accomplished and what needed to be carried over to the new sprint, preparing us for a new sprint and beginning the cycle anew.
So throughout the past year, we spent a lot of time researching Apache Arrow and developed a proof of concept to measure the efficiencies of it. More importantly, we developed a technical report to sort of condense our findings and diagrams and so on to help with future development. This is an open source project. We developed an integration plan with all the files and specific methods that need to be changed, what they do currently and what they will do after we refactor them. And we began integration focusing on very specific cases, starting with CSV files and then continuing to expand to more general use cases, making things more dynamic as we go on.
We also faced a number of issues during our elicitation and development process. Because of how new Apache Arrow is, there's not a lot of documentation available out there in the wild for understanding how it works, which led us to significant research help. We also ran into significant difficulties in setting up BeakerX. As the instructions from its GitHub repo returned errors we were unsure with how to deal with. In addition, our methodology did not entirely line up with the structure of this project, as it was hard to quantify effort spent on research, which led to the team to lag behind on our timeline. This, in turn, led to results appearing pretty late in our development process and forced us down a death march towards a timeline. In terms of the future for this project, once again, it is open source, and the progress that we made can be easily picked on by any other teams. Our team does tentatively plan to continue work on the project post-graduation, with focus on adding support for other data formats aside from CSV, such as the aforementioned Apache Plasma. Any questions?
The chart that you showed with the times for like the JSON versus Arrow, did you guys collect that data or how did you run trials on it to get those times?
So overall, we ran dozens of trials across different machines. I think this specific graph is like the average of a couple of trials on maybe my laptop, but this is just like one example of the data we collected.
Was there ever a contingency plan for if Arrow just wasn't going to work out?
So a contingency plan that we had set was if not use all of Apache Arrow, then to rely on the open source components of Apache Arrow that have been already established and contributed by other companies into the project. Because Apache Arrow didn't start off as this kind of monolith. It's very module based. There's a lot of stuff that you can use from it without having to utilize the whole entire process. We did have plans on using some of the optimizations and serializations if zero copy memory and in-memory storage wasn't going to be working out.
Okay, everyone, if we could just have your attention. Sorry about the little break. But we are the Disaster Communications team. My name is David, here with Joe, Jason, and John. And our sponsor is Dr. Clark Kilgraff, as well as our faculty coach being Oliver Wang. So to get right into it, cell phones, they're ubiquitous and they have a lot of super great uses. We all know that, whether you're texting friends, checking your emails, or playing Clash of Clans or whatever. But when we're not on Wi-Fi, we run into a few issues because we're relying on cellular providers. So we looked at two groups that are affected by this sort of problem. So first off is just your standard user. That's me and you. We use cell phones, most likely. I mean, who doesn't? And we have a few questions or problems when it comes to that service. So one of them is, I don't know, which provider do I pick? We have AT&T, Sprint, all those. In my area, like, AT&T could be better, but when I go back home, maybe it's Verizon. So if I'm moving somewhere, maybe I want to choose my provider based off that, or maybe I just want a little insight into who's doing better. There's other questions, such as maybe I'm planning a trip to the Adirondacks. I don't know when I'm going to have cellular service. It's spotty there, but there's going to be certain areas where I have it, certain areas where I don't. So maybe if I want a little insight into that, well, I need something to give me that insight. The other very important group that relies on cellular service very much is emergency personnel. They communicate a lot with LTE communications. They use not just normal call, not just radios. They use a lot of voice communication, video communication, as well as just they need raw data to communicate and respond to these natural disasters. So yeah, cell carriers, they only voluntarily provide coverage information every 24 hours. In the case of a disaster, we need a better response because 24 hours, it is a long time, especially when there can be users who, or there could be citizens who are in need of help. They can't call 911 if they don't have service. So that's very important. A lot of the coverage restoration strategies used currently, they need to know how the tower is doing. And if it's the government doing this, again, they only have access to this information every 24 hours, unless the providers choose to be nice and give it to them. And we found that's kind of unlikely. Additionally, the coverage restoration strategy that we're going to briefly go over today probably, it relies on that knowledge, obviously. The other thing is providers, they do have a history of throttling emergency responders' cellular data. We all know about probably Verizon throttling, I believe, is the Santa Clara Fire Department when responding to a wildfire. And yes, Verizon said there was a mistake and it shouldn't happen again, but that's something we want to keep our eyes on because someone needs to hold these companies accountable if that happens in the future. And throttling isn't always an obvious thing. You know, sometimes it's happening and you don't really know it, or sometimes you don't really know it until you really, really need that data or that bandwidth.
So to address a few of the goals that were set forward by our customer, first and foremost, our system is only effective if we have a significantly large database. So we wanted to scale up our application to a lot more users. So we wanted to be able to release this to the RIT Alumni Network, which has over 100,000 users that we would potentially be bringing into the system. And we needed to make sure that we were able to handle that load with our application and our servers. Furthermore, we just had a bunch of bugs that were crashing our app and we didn't know why they were happening, so we needed to be responsible for finding and fixing those. And as a part of that, we had to figure out a good way to identify, track, log, and then go about fixing those bugs. And then there were just some miscellaneous enhancements, some UI and user experience enhancements that were added to make the app more usable, both for collecting the data and for just the user using it for their own purposes. So another part of that was also setting up our server on a virtual machine. Previously it was a physical box sitting in an office on campus, but now it would be an actual virtual machine, which is how things work now. And one of the benefits was that makes it a lot more scalable. It's able to handle a lot more users pinging the server at once. And then we also had to look into some other options for identifying if there's any traffic shaping, which, if you don't know, is basically throttling only certain types of data to make sure that, only calls can go through, and we're not going to be addressing any video data or anything like that. So this is something we wanted to be able to track, and we needed to look into whether or not it was possible at all. And then a few other just requirements for the application as we were going through the development. First and foremost was upkeep and maintenance. We were inheriting a working, mostly, version of the app, and we needed to make sure that we kept it working as best as we could as we were going about implementing our bug fixes and new additions. And we also had to bring it up to spec with the new version of the Android API and make sure that we are compliant with all of their specifications that they added. The other requirement, like I said, was scaling up. The big interest is reaching out past the Rochester area and a few other places where people using the app already are, and really building out to a nationwide coverage map. And then we had to add in some enhancements, like I said, a lot of usability stuff. But first and foremost, we needed to maintain data anonymity, just to make sure that we weren't releasing any personally identifiable information, or frankly even storing it in the event that anything gets incidentally released. So a few of our key accomplishments: we did set up that virtualized server, and we did get that running so that our app now references that server instead of the physical box. We added in some new features, including the ability to manually control map scaling and combine carrier data together, which we'll go through in our demonstration later. And then we did research some feasibility of running current implementations in the background and passively tracking traffic shaping. Unfortunately, those weren't things that we could implement, but we did have to research a lot for that. And then first and foremost, we implemented a new system for tracking our crashes and bugs that were happening, which made it so much easier for us to address these and get them fixed, which then we proceeded to do. So now we're going to go into some brief demonstrations of our product. So the first thing is when we load into the application, we have this splash screen, which you briefly saw there. That explains what the permissions are that we're asking for and what we're using them for, because we need access to things like call logs and your file system in order for the app to run. And we want to make sure that the user is aware of what's going on in their phone. A lot of people nowadays aren't so keen on just blindly allowing apps to view their call log, and we want to make sure that they know why we're poking around in there. And then that brings us into the actual measurement of the bandwidth test. These do run automatically infrequently, but it's the way to track how fast your network connection is. My phone was not on very good connection at that time. So then another thing, like I said, we have manual zooming of our heat map. So we have a map which lists all of the coverage areas, and each of those squares aggregates the data in there to produce an average speed test result. Before, when you zoomed in, the boxes would get smaller or larger to stay a generally consistent size. But if you wanted a more generalized view of all of Rochester, you couldn't get that. What we did was we added on the right, you can see a manual zoom, which stays the same size for those boxes as you zoom in or out, and you can manually change the size. So if you want a very granular box size while you're zoomed out, you can do that. Or if you want a very large box size while you're zoomed in, you can also do that. And then another thing is we wanted to be able to display what the best and the worst coverage in a given area is so that you can better compare against Sprint, Verizon, or whoever else might be in the area. So with this, we're able to aggregate the data, find good coverage areas, bad coverage areas, and determine who has the best results. So in addition to the existing ability to just look at only one carrier, now we can aggregate that data, which makes it a lot more usable for a typical consumer.
So this is the basic architecture of our system. There's a few things that weren't in the scope of our work for the year. So I'll just mention that those are there, and it matters because we needed to make sure we didn't break them, or sometimes we relied on how they functioned. So obviously what we just showed you was sort of the base of the work, which is the Android application. Simple as that. And that uses a server, what we call the bandwidth server here, to run those download and upload tests and just see how fast it can download basically junk data from there or upload. So going up top is our Flash server, and that is our backend for basically what the app does. So as far as storing results, presenting all that information onto the map, which is a complex process, that's handled on the server, and obviously it has that connection to the database. And then down low is the Django front end. That's the incident commander portal. That's something that, again, was sort of out of scope, but worth mentioning. It's part of our architecture. One other thing I wanted to touch on was that as part of our work, we did upgrade to a new server. So what that meant was taking that Flash server and that Django front end and moving those onto a new box seamlessly so that we can still have our same connections here. Everything works as normal without data loss. And yeah, that was a big concern that we did that seamlessly. So there were a couple of design decisions we made and we wanted to highlight for you all tonight. Again, we inherited this application from a previous team, so a lot of past design decisions, a lot of the architecture was sort of built out for us. Most of that diagram that I just showed you was built out for us by previous teams. However, there were many decisions we made throughout the year. A lot of them were to do with that upgrade to the RIT alumni network, not upgrade, but distribution and scaling up for a lot of users. As well as we just had some decisions to add a little more usability, a little more flex when it came to navigating that map and understanding what is this data I'm looking at. So probably one of our bigger decisions, and especially relevant to our scalability, was the server decision that we talked about. This wasn't as straightforward as we're making it sound, because first of all, we risked investing all this time into putting together a new server and moving everything, trying to move everything from the old server over, and having that fail. Things could have gone wrong. We realized that risk. But if you look at this chart here, we saw way better response times from just simple web requests from our app. Those are, again, just simple sort of CRUD operations, I should say REST operations. We saw significant improvements in that, obviously, as well as we saw random crashes in the old server, which are very bad, obviously, because users using the app could suddenly lose capability of using it in any way. And those crashes we could not explain. But when we moved to the new server, that concern went away, which was very good to see. And definitely showed how our risk paid off. The other cool thing about moving to a virtual server is it does, first off, give us a little more flexibility because we know how to move from one box to the other in a very sort of simple way now that we figured it out. But also it allows us to scale not just vertically but horizontally, as in we can have a lot more servers working when we have more users if we see the demand is required for that. And again, that's something that will have to be sort of ad hoc. Do we see a lot of demand? Is the box not handling things well? But that's something that can be a lot more easily done this way now that we have the new server. Another decision with a lot of the features that John actually showed you in those previous slides, we had to decide whether we wanted to implement a lot of the coding, a lot of the implementation on the server or on the app itself, as far as where are we changing the code. So with the app side implementation, this was sort of the obvious one in a way because it was a lot simpler. Just looking at, well, first off, we had been working solely on the app at this point. When we were making this decision, we were familiar with it. We knew how it worked for the most part, but it had its downsides, obviously, which was slower performance. We would be pulling in data and then sorting through it and doing redundant operations in that way, as well as our app had a few memory problems, and doing more work on the app side would make this even worse. Obviously, the plus side, again, just changing the source code on the app, a lot more simpler for us, kind of a tempting route to take. What we eventually went with was the server-side implementation. There was a little more complexity in this. First off, again, we didn't touch the server code until we had worked on these features, so we weren't really sure what to do. It required code changes, and not just the server, but through actual database code and the client. But we found this was a lot faster, so it was a really good boon to us.
So we, of course, ran into some challenges along the way. No project would be complete without them. And, well, the requirements that we were working towards did occasionally change. It's kind of why we have agile processes in order to account for those changes. But they were certainly something we had to account for. And furthermore, the Android policy set that Google enforces on the Google Play Store pretty much changed out from under us, where they took a much harder line towards a number of the behaviors that our app relied upon in order to function. And so then we had to go and change a couple architectural decisions, a couple permissions, various things like that. And of course, stability. That was a major challenge at every single step of the way, every update we provided, we had to make sure that the stability of the application was at the forefront of our minds. So, some additional challenges. The app's a fairly complicated one. Obviously, we inherited it. This is a multiple team project where one team developed it and another goes and develops more. And that inherently introduces its own sorts of complexities as different teams' design philosophies get welded together. We have, as I sort of alluded to earlier, we needed to ensure, in fact, other team members mentioned it, the privacy concerns were also paramount. You need to make sure that those concerns were tracked and upheld. We need to make sure we were not collecting any information we should not be collecting. And we need to make sure that we are handling our information in a safe and secure manner. And there's also that unexpected event of being removed from the Google Play Store, where Google basically, looked at our app and said that they did not like the way we were doing a couple of things. So we got pulled off the App Store very, very late in the game. We had to run around and try and get that all patched up. As it stands, we have the new updates in the store. We just need to get it reviewed and approved on that end. So things went well, though. It was not all challenges. Some successes were how this semester our team roles, we optimized them. We allocated tasks in a more efficient manner in order to take advantage of all our specializations. We continued to study the code itself and understand the project intent on an overall level. And we, as I said, there was that very late in the game problem that cropped up at the Google Play Store. But I think we adapted to it very well. We went in and we made sure to account for the things that needed accounting for. We made all the changes that needed to be made. Things went fairly smoothly there, if rapidly. And the virtualization of the server was rather successful. It's virtualized. We just took the box and made sure to bundle it up and transfer it over. It's now working. We can actually access it from our test devices. And that went very smoothly. Now, we could have improved the amount of documentation we produced. That would be definitely a benefit not only to ourselves, it would have been a benefit, but it would be a benefit to anybody who came after. And also ensuring we have access to the Google Play Store notifications and information on a smooth basis. And we learned a bunch of lessons about this whole industry.
Okay. So going forward for other teams, just kind of continue work that needs to be done, maintenance for sure. The app was inherited from a few teams, so there still is a little bit of buggy code here and there, or dirty implementation here or there. A lot of our work this semester, we dealt with moving our current physical box to the RIT VMware data center.
And in doing that, we did see quite a bit of improvements to response time, as you saw from the graph. Prior to that, we were dealing with issues where we would literally load so much into memory that we would begin swapping, and then all of our requests would time out. So fixing that really helped a lot. Loading the map now happens a lot quicker, so that's definitely a UX improvement. Going forward too, also, one of the main goals for this is to, if you have an area that loses infrastructure, to be able to provide a temporary one. So being able to take this crowdsourced data which says, okay, there's an outage in this area, flying a drone that has an LTE base station on it that can provide a temporary infrastructure for first responders and also, just end users in that area. So to simulate that, that's something that definitely needs to be worked on, kind of more thought into how we can chunk things apart and load them in smaller pieces, because we would be running on an embedded platform, so just resources available is much, much less. And also to being able to get a little bit more visualization of what data we have collected. There's a lot of data there. It could be extrapolated on in many different ways to look at many different metrics. So just adding more information in regards to that would definitely help. Any questions?
I have. So you mentioned that one of the goals was to address your 100,000 alumni downloading apps and community. So I'm wondering, how did you test that? Did you actually succeed?
So we did do a fair amount of stress testing with a program called Loader.io. And with that, we simulated right around 10,000 to 15,000 concurrent connections, and that was right around like a half a second to a little bit less response time, so like 500 milliseconds to 400 milliseconds. So we definitely increased that from the previous implementation, which would eventually just hit a point where you wouldn't be able to get any response because you would have so much in RAM that you would swap everything, and then at that point, everything would just time out.
And it should be noted that this is 15,000 or so simultaneous users.
Right.
Not just people who have the app, but people who are using the app at that exact moment. Right. So.
And the tests will be distributed because a user only pings the server once every few hours. So even if we're at several 100,000 users, there should never really be a circumstance where we hit 15,000 at once.
And what actions were the singular users taking?
We were using basically the same endpoints that the app would, we were using the same endpoints the app would use as far as loading in data from the map or just getting general data in. So it would simulate just the app talking to the server just like any user would.
During the live demo, I saw what looked like a heat map of signal or service in the Rochester area. Where did you get that data from?
That's the data that our users collect. So when a user runs a speed test, that speed test result is logged on our database. And like I said, we basically pull in all of the speed tests in an area and average out what's in that box to determine what number to put up on that heat map.
That was real data?
That is real data.
If a user doesn't have one of the main wireless networks you listed, like I don't think Project 5 is on there, would that still, how do you manage that data if it was a different node?
It actually utilizes the network, the network of the tower that you are connected to. Project, I think they piggyback off of the AT&T and Verizon towers mostly, and some others, but so that would show up based on which one of those you're connecting to.
So if it was like another one that like had their own cell tower, then would you be able to filter that option, or would it just be specifically covered?
In the U.S., those are the only 4 that have major cell tower networks. But if you're connected to, for instance, a municipal one, that should pass along whatever the credentials it is registered as. So it should show up in our database, actually.
Yeah, in the future, it would have to be added in to handle a new carrier.
Yeah, right now they have a 6-bit code, which is the carrier ID, so we would just have to add new carrier IDs.
There aren't very many of those, though, and most of the ones that are there that are not the main ones are ones which have been bought up by, like AT&T owns a couple of cell networks, which operate as subsidiaries. So. That's that thing.
Robert, you're kicking it off.
Go ahead.
I'm not ready for anything.
Gonna wait a second. Hello, everybody. Hello. Okay, so my name is Robert Nill. That's Justin.
I'm Byron.
Paul. Alex Gearing.
And we are Web People, bringing you Full Shelf, our mobile app for Wegmans. And we want to give a big thanks to our sponsors, Jesse, Rich, and Rick, and our coach, Professor Malakowski. So today we're really briefly going to break down our presentation into 4 main sections. We've got an overview of the project, so I'll talk a little bit about what the product is and sort of what the main use case is. I will go over some themes of our semester and some really important events and areas that we focused on. Then we'll have more of a retrospective focus towards the end with the what went well, what didn't go well, and then we'll end up with a product demo. So real quick, we want to ask, what the problem is and how do we solve it, and that's a very good grounding point for understanding what this whole project is about. So our primary use case can be fit into something like this, where we have an executive going into a store at Wegmans, a Wegmans executive, and perhaps they see an empty shelf and they want to understand, well, why is this happening? Is it somewhere in the store that it hasn't been restocked, or is it perhaps somewhere further along the supply chain? What's happening. If the store manager doesn't know what's happening there, we're going to have to go through a lot of people, and it's going to be a big effort. At the end of the day, that's just a really dangerous situation to have happen at any retail store. If you have an empty shelf, that's a bad impression that's going to happen on your customers, and at the end of the day, they could end up giving their business somewhere else. So what we want to understand with this project is what's causing those out-of-stock situations. They could be caused, as I mentioned before, by a variety of things along the supply chain. It could be further up, could be in-store. Maybe there isn't a problem and it's going to be replaced. Maybe the tag needs to be changed. And at the end of the day, we need to give our users, our executives, possibly managers, some actionable data that they can say, okay, well, I know what's happening here, and I know who to talk to, or I know what action I have to take just based on, scanning a barcode, and I know what to do now.
All right, so next I'm going to talk about our core product, what we came up with was our minimum viable product. It was a mobile application that is targeting both iOS and Android devices, so cross-platform. And it's going to take advantage of 2 main capabilities of phones, which is the location and the camera. The location gives us which store that the phone is currently located at, and the camera is going to scan the barcode for us so that we can then come back to the executive and show the actionable data that Robert talked about and allow them to actually go in and find out exactly what is going on and go in and fix the problem so it's not happening again.
So we're going to briefly address our process. We're all very familiar with Scrum by now. I don't really want to spend more than a minute or two talking about this. But basically we use Scrum, 2-week sprints, pretty straightforward. This is what we did all year. It worked pretty well for us. Kind of 2 changes from last semester is this was very much like a prototyping mindset, where we had a working app by the beginning of the semester that we finished last semester, but not like production ready app. And so every week it was bringing a new iteration to the sponsor saying, hey, how's this look? How can we make it better? So that was one of the big changes from last semester. The other was we did a lot better job of siloing work. So individual members of the team worked on very specific types of work, and it just helped us specialize in work, make it a lot faster, a lot more efficient. Our schedule was a little bit weird in that we actually stopped adding features fairly early in the semester, about halfway through. Basically, we wanted to have a ready-to-go product by the end of the semester, and so we stopped adding features halfway through the semester and really stopped doing most of our code with 4 or 5 weeks left in the semester, just because we wanted to give a stable, not any weird things product off to them.
So, like Paul mentioned, the main theme of our semester was rapid prototyping. These prototypes really revolved around the UI. So, like Paul mentioned, we did have a generally working app at the start of this semester. We did a good amount of development last semester. So we had 2 back-end services that didn't really change much. We had a little bit of additions this semester, but for the most part, we were really iterating on the UI. So here you can see some of the wireframes that we have. These are some of the later wireframes that we came up with. First, we started off with like a rough idea, then we updated them as we went, and then we're also iterating on the actual prototype that we had. The reason that we really wanted to focus on the UI is that early on we identified user adoption as a high priority and also a potential risk. So the users wouldn't be necessarily very tech savvy, so anything that was too hard to navigate through or deal with would sort of put them off and make them less likely to actually use our product. We also wanted to make sure that the data we were showing them was consistent with data they might see in other systems. So there are some existing systems that collect similar data, so we wanted to make sure that the language on our app was similar to the language they might see other places. So we really worked on iterating on the UI and then really refining the usability of it. What enabled us to do this was that we had a strong existing process and also the sort of the architecture that we came up with last semester. So like Paul mentioned, we had a very iterative process, and we did this intentionally to help mitigate any risks later on. So we were actually able to create a lot of rapid changes on the UI in order to make it a more usable product. For example, the flow of the application wasn't really nailed down until partway through this semester, and then we eventually refined it into basically just a 3-screen process, which made it a lot more usable. And then what really helped us out was our architecture. So we used the platform Xamarin, which is a mobile cross-platform application. So it allowed us to have one code base for both Android and iOS. So we could create one code change, and it would affect both platforms. And then it also let us leverage the MVVM pattern, so we could edit the logic of the mobile application without really affecting how it displayed, and then also affecting the display without editing too much of the logic. So it really helped us iterate on just the view without needing to make too many changes. One of the main things we focused on this semester was user testing, and this is what really drove those UI iterations. Each meeting, we basically just showed a new build of the app and then figured out what looked good, what needed to be changed, and then next meeting come back with a new iteration. So at each of our meetings, our sponsors were there, and they're technical business users, so they have that domain expertise where they would understand what the data should look like, how the language should be, and if there's any anomalies that we're displaying. But they're also sort of understanding that as we're developing the application, there are going to be some bugs, there will be some hiccups there. So if we say, okay, we have an existing issue here, but we focused on the display of this data, does that look correct to you? They were able to give us really useful feedback doing that. And then some of the metrics that we collected really helped drive our prototyping and our iterations. So last semester, we started collecting a lot of metrics that we more passively collected this semester, specifically like our velocity for our stories. And we also made some changes last semester about getting more visibility onto our PRs, and that really paid off this semester. The main thing that we focused on very actively this semester was our backlog bar. So in addition to the prototypes each meeting, we also reviewed the backlog bar, and what this was we displayed our backlog, and we had a clear literal bar on it that said, we are going to make it to this point. Is there anything below here that you think we need to actually complete? And then we sort of had a strategizing situation. Well, what stories do we need to swap out in order to complete everything you need? And actually, for the most part, our velocity was right on, so we didn't really need to swap out too many things and did end up getting down to that backlog bar.
So along with the rapid iteration theme of this semester, one of our big goals was to hand off a working product. We wanted something that they could just jump right in and use. We didn't want to kind of leave it like half done. We wanted this to go into like continued development and use. So one of the main things we did was our pipeline work. So we have build pipelines set up on their servers. They have an Azure DevOps account that we use that builds all of our systems and deploys them and builds the apps and has APKs for them and whatnot. So all they're going to have to do here is point the backend services, switch it from my Azure subscription to their Azure subscription, and it will be all set up. So in terms of continued deployment, it's just change where it's pointing. Really easy. Just a real quick refresh for those of you who saw our architecture last semester. Hasn't really changed much. We have the app layer, which is just like what the user uses. And then we have two back-end services. One is kind of the business logic. One is just kind of aggregating all the data from our different sources. So both of those back-end services are deployed by pipelines, and then the app, both the versions of the app are built there. In terms of other stuff we did, we have a document that was basically a living document throughout the semester that was also iterated on with our sponsors' help of like, what does it take to develop this? How do you set up your local environment? How do you run it locally? How do you test it locally? All the different things that you would need if you're going to like pick up this project and start working with it. The code base is already in a repository they own, so we didn't have to worry about any of that. And one of the things we did fairly early on in this whole process is follow Wegmans' style guide, their like build patterns, their Git branching stuff, basically so that when a development team picks this up, it will look just like what we've been doing, but with different people running it. You can't get it perfect, like picking up a new project is always hard, but we wanted to eliminate as many of those blockers as possible, just so that it would be easy for them to work with. And then in terms of future work, that backlog bar that Alex was talking about, they're able to just look at, okay, the backlog bar is here, that's where we reached. Everything below the backlog bar is what there is left to do in the project. So there's a really clean, like, where do we go from here kind of thing.
Okay, so like every other group in the room, we had some stuff go pretty well and we had some stuff go pretty not well. I'll be covering what went well, and we're going to be breaking this into two sections. We're going to talk about what went well with our process and what went well with our product. So as mentioned before, we were using Scrum, and we were able to successfully take feedback from our sponsors and rapidly iterate on our designs. So we managed to stay agile, which was super important, because if we were doing Scrum and not being agile, we had a problem. For one example of this, we actually had a very late in the game change to some of our data contracts and a big UI overhaul, and we were able to get all that done before this presentation back on April 2nd, if you remember the slides earlier. So everything's been going real well. Our communications with our sponsors have been consistent. We didn't spin our wheels or have useless meetings. We kept our email correspondence organized, going through Robert and Jesse for almost everything. And our planned deadlines, we met them all successfully, and we're real happy with how all this went. And then for our product, we're pretty happy with our product, and we hope you guys are happy with our product too. We think it looks pretty professional, and we think it's a little going to be easy for the executives at Wegmans to use. We did have to adjust some stuff from our wireframes to better fit the Xamarin Toolkit, but everything else seemed to go pretty well. We have our MVP, no problems there. Android and iOS, we have both of those platforms working. We'll be demoing on iOS in just a little bit, so you get to see that. And then our system was well documented, both in the code and in the documentation Paul mentioned earlier.
All right, so not everything can go well, obviously. So we did attempt to address everything we could during our process. As we keep saying, it's iterative, so every single sprint we were able to adjust and come back and improve. But going back and looking through hindsight, we can see a few different things that we probably could have improved on and done better. First of all, we could have utilized our metrics more appropriately. Like we said, we talked a bit about the backlog bar and how well we did that. However, we had some other data that we measured and didn't really take full advantage of. And looking back, we could have used that a little bit more. Second, our adherence to our process. While we did keep our iterations in Scrum going fairly well, later on in the semester it diminished a little. And it's just going to happen. We are seniors, so that happens. Three, our productivity this semester was a little bit more inconsistent. Every week, everything kind of varied because we had interviews. Sometimes we got sick and caught each other's sickness. And we probably should have started iOS a little bit sooner. It is a cross-platform Android application, and and iOS application. So we started with Android and eventually moved to creating iOS. But the way Xamarin works, we should have done it at the same time. In retrospect, it might have been better to make a native app but now that we're handing it off to Wegmans, and it's all set up, it probably will be better. So now we're going to do a final demonstration of what the app can do and what an executive going to the store is going to interact with. So here, we were going to be using our iOS application. Not link. I'm sure an executive will be using LinkedIn, but here we have our application full shelf running on an iOS, starting up. So here you can see the store selection. As we are here at RIT, it has automatically selected the Marketplace Wegmans, which is just down the road. But you can obviously select whatever you want, but Marketplace is good for our purposes. You can manually enter a UPC here, pretty normal, but that's not fun. As you can see, scanning the barcode, infinite barcodes. As you can see here, this is a page where you scan the barcodes. One of the interesting things about our constant iterations is this was originally just a viewfinder, and it was a little hard to tell where to put the barcodes, so we put this red line and blanked out some of the area that you don't want to put the barcode. So here we have a barcode of cinnamon squares that, as you can see, just got scanned. You can see various information about it in the store. It's perpetual inventory, the last time an employee came and went and cycled that, when it's expected to get its next delivery, the last time it was sold and invoiced. But this one doesn't look like it's out of stock, so that's not very interesting. Let's take a look at one that is out of stock. So I've got some tiger sauce here, and it looks like it should have inventory, but it doesn't. I'll hand this over to Justin to explain what's going on here.
Hello, so I am the guest speaker. So how Wegmans kind of does their causes for what's wrong with a product when it's out of stock is they have like a list of causes. So you're going to see this where on this particular product it has possible shortage or misshipment, and then it has 3 days where it sold more than they were expected. And then Wegmans has a bunch of fancy logic where it'll look at this big list of things and it'll decide what's the most important and list that up at the top. So DC caused. That doesn't mean much to you and me, but this is like Wegmans wording, and we are very specific with this, so the executives would know exactly what was going on by using their language. Okay. Here we go.
All right. And with that, that ends our demo, and we thank you and would like to take any questions that you have.
So
when you scan an item that's off the shelf, is there like a notification about the store know that like this item's like this snacky, or is it just saying like why?
Nope. So one of the things we kind of worked out with the sponsors early on is that this is only going to be an information provider. It's not actually going to take action, send information, any of that sort of thing.
saw Billy next.
Yeah, I noticed something that you did was you siloed your work amongst your group, which I think was pretty cool, pretty smart. I wonder, have you guys ever run into an issue where somebody ran out of work to do in their silo? And if so, what did you do in response to that?
Justin, do I take that?
So I did a lot of the back-end stuff, and a lot of that was done by the end of last semester, and then we came back and added some extra stuff in this semester. So I actually jumped over to the Android silo, and I've been helping mostly Robert get some bugs fixed on Android and getting everything up to speed. So that's how we handled that.
Was the data like the DC cost or whatever, was that like actual Wegmans data, or was that not?
Robert, you want to take that?
Okay, so for this presentation, we're currently working off of mock data, but we do have the capability to switch out a line of code and work with real data. And so the real data is actually working now. We just wanted to make sure that we have something very reliable and steady to show you.
That mock data isn't data we made up, though. That is data we just took from a product and stuck it into a mock object. That way we could show it to you guys. So that is what Wegmans data looks like.
How do you handle what's true? Because I assume you don't want like anybody just downloading your information.
So the app is not in the store. It's one that they have a way of distributing. So all of their executives are given phones by Wegmans, and they have software on that to distribute apps to it. So it will just be distributed that way.
I also have a follow-up onto that. So we did also discuss early on last semester, the possibility of adding in user login. We have that tracked in our backlog below the backlog bar. It's pretty low priority because that wasn't something that we wanted to have in scope for the project, so we could get all of our features done. But it was definitely a concern, who has the capability to access this information.
Working with Xamarin can be interesting, especially when you're trying to do iOS and Android. So I was wondering if there was any situation you all came across where like we were trying to work with a UI element where it showed up in Android and it was broken in iOS.
I have
a lot of us can talk about this.
Yeah, we can all probably talk about
I have
this.
a personal vendetta against Android list views because if you don't use their specifically built-in text renderer and you add a bunch of items to your list with text, that text will not render correctly. And it'll just be like, elements will start duplicating themselves or just like truncating themselves to like 1/4 the string. And there's no rhyme or reason to why Android would do this to me, but it did it to me. And it made me real sad.
So something major that we had was a problem that lasted about 3 weeks where after we had started putting iOS on and started actually building it up after the Android project, we had an issue with a status indicator, something as simple as just indicating that it had already scanned something and it was ready to go to the next page. It worked in Android, but iOS just didn't want to display it, and we ended up having to completely reconfigure the view in order to make it work, and that took 3 weeks to get done.
Yeah. So there are also some elements in Xamarin that are non-native that they try to use for both iOS and Android, other this view being one of them, but it does not always work for all of our use cases. Being the person who drove the wireframes and then wanting to convert those as close to truth in the UI, I found that a lot of elements that, maybe are traditional were not possible in Xamarin natively. So you either have to download some plugins like we did for getting our pop-up view, or you're going to have to use something in a experimental release, like you have a new list renderer, but it's not in the build that we have because we wanted to make sure we were running a stable version of Xamarin.
Along those lines, you said, we probably should have, could have maybe made the native app. Given the time frame and what you know now and the setbacks, do you think you would have achieved these results?
I think we may have gotten more features done if we had gone native. However, the fact is we have to hand it off to Wegmans, and now that it's kind of already set up to this point, they can go on and get this more stuff done faster for the next group or Wegmans if they choose to continue on with this. So while it may have been a disadvantage to us in the future, it's going to be an advantage to them.
And you probably documented all those red flags, right?
Yes. Many red flags have been put in the handoff document.
Any other questions?
Thank the team.